When writing a polynomial function given its graph, you need to know the function's intercepts. Knowing these facts, you can work your way backwards towards what the function is. Some of these graphs actually can have more than one possible answer, but we're going to focus on the simplest and easiest of the solution. So we have this polynomial function, and we're going to write a function that represents this graph. So we can see that the graph intersects the x-axis at 0, touches it at 1, and then crosses it at 2. So we're going to have 3 zeros here. We're going to have x equals 0, x equals 1, and x equals 2. Now we're going to work our way backwards. We're going to move everything to one side instead of equal to 0. So x equals 0 stays the same. Subtract 1 over, x minus 1 equals 0, and subtract 2 over, x minus 2 equals 0. Now we have these 3 zeros, but we have to take into account that 2 of them cross and 1 touches. So this crosses and this crosses, but this actually only touches. So if it crosses the x-axis, it has to be an odd multiplicity. 1, 3, 5, 7, so on. But we're going to choose the smallest and easiest. We're going to say 1. Whereas this 0 touches the x-axis, so it's have an even multiplicity, 2, 4, 6, 8. But again, we're going to choose the easiest one. We're going to say 2. So multiplying these all together, and I'm going to write it over here, we're going to get x times x minus 1. And I'm going to say this is a square because of even multiplicity, and then an x minus 2 equals 0. And since it crosses the y-axis at the same place it crosses the x-axis at 0, we don't have to worry about a y-intercept on this one. So this would be our function, and I'm going to write it in function notation. So f of x equals x minus 1 squared, x minus 2. Now this will be the answer. This is the polynomial function that represents this, but if you want to actually distribute it all out, you can also get an answer that will be x to the 4th minus 4x cubed plus 5x squared minus 2x. Kind of make that 3 look a little bit nicer here. And this would be the representation of the polynomial as well. You can either keep it as a factored form or distribute it out, whichever you prefer. Here we have this polynomial function, and this graph is going through -1, and then through 4 on the y-axis, then through 1 on the x-axis, and then touching 2 on the x-axis. So we again have zeros at x equals -1, x equals 1, and x equals 2. I'm not writing in this where it crosses the y-axis, not quite yet. I'm going to save that for last, and you're going to see why in a second. So I have my zeros, so I'm going to move everything over to one side and set them equal to 0. So x plus 1 equals 0, x minus 1 equals 0, and x minus 2 equals 0. And now, again, I need to see what the multiplicities are. For -1, it's odd, so I'm going to say it crosses, so it's a 1. At +1, again, it's odd because it crosses, so I'll say this is also a 1. And at 2, it touches, so I can say it's even, and I'm going to say it's just a 2 for a multiplicity. So when I bring them back together, I'm going to get x plus 1 to the first, x minus 1 to the first, and then x minus 2 squared equals 0. Now this is what my polynomial function is so far, but I haven't taken into account where it crosses the y-axis. So first off, I'm going to write this in function notation. F of x equals a x plus 1, x minus 1, x minus 2 squared. And I wrote a here because I need to know what its leading coefficient is. because it goes through the y-axis at some point other than 0, 0, there's going to be some a value. So this is where my y-intercept comes in. 0 is going to be replacing x, and 4 is going to be replacing y. And when I do that, I'm going to have to solve for a. So that's what I'm going to do. So 4 equals a times 1 times -1 times -2 squared, because all the x's go away when I replace them with 0. So when I work all this out, I'm going to end up getting 4 equals -4a. And so when I solve for a here, I'm just going to get -1 equals a. And now that I know what a is, which is just -1, I'm going to replace a up here with -1. So my new function, finally, is going to be -1, or just negative, x plus 1, x minus 1, x minus 2 squared. And you are welcome to FOIL it out if you want, distribute it all out and get an expanded function, or you can leave it in the factor form. I'm just going to do that because it's just the same answer, so there's no need to go any further unless required.